Now, when we're dealing with hybridization schemes, in those previous problems, those were not hybridized. When we were finding out the lone pairs of electrons and how many unpaired electrons there were, so however many unpaired electrons there were, that's how many bonds it can form. That was for elements that were not hybridized. So now we're looking at hybridization schemes, and the example here is sp3d. So some electron rearranging has gone on there. So we can no longer do it with the little lines for the orbitals and put the ups and downs arrows for the electrons. But the good news is that this is just as simple. You just do it differently. If they're hybridized, first of all, this sp3, you notice there's no 2 after the letter S like normal. Well, that means that's one of the clues that it's been hybridized. The S has donated one of its electrons to a P or a D, so they can all balance each other's energies out. So uh, since there's no number written after this S, we can assume that this is just going to be a 1 instead of the normal 2 that comes after S usually. And since there's no number written after this D, we can assume that's going to be a 1 as well. And the P has three electrons in its orbitals. So all you have to do to find out how many bonds that this is going to make is you take the 1 from the S plus the 3 from the P plus the 1 from the D. And that equals 5. So there are 5 possible bonds that this hybridization scheme can make. And that's all you need to do to find out how many bonds a hybrid element can make.